Good day, Year 9. Lovely to have your class again. Today's lesson we're focusing on index law 3 and zero power. So our learning intention is to use index law 3 and zero power to simplify algebraic expressions. Our success criteria first will be to use the method of expand and simplify, and second, to be able to apply index laws 1, 2, and 3 and the zero power to simplify algebraic expressions. From our previous lessons, we already know basic algebraic facts. We know basic integer facts. We also know measurement and how to solve equations. All these will come handy as we progress through this lesson. Now, the first one is to expand and simplify based on our first success criteria, expand and simplify. So, for example, if I've been given 5 to the power of 3 or to the power of 2, as in this question here, remember, 5 to the power of 3 is 5 times 5 times 5. And because it is squared, I'm still doing 5 times 5 times 5. In other words, 5 to the power of 3 all squared is simply 5 to the power of 3 times 5 to the power of 3. So this 5 to the power of 3 is 5 times 5 times 5. And the second 5 to the power of 3 is also 5 times 5 times 5. So 3 times and 3 times. So altogether, 5 multiplies itself 1, 2, 3, 4, 5, 6. So 5 to the power of 6. Already you'll be able to observe some pattern, but let's keep going. We'll get to the pattern later on. Let's have a look at m to the power of 5 or to the power of 4. What this means is that you've got m to the power of 5 times m to the power of 5 times m to the power of 5 times m to the power of 5. Now, if you recall law 1, here is our expansion. But if you recall law 1, because the base is equal to m, because the base is equal to m, and it was m to the power of 5 multiplied by m to the power of 5, m to the power. When you multiply numbers with the same base, you simply add the powers. So this is simply the power of 5 plus 5 plus 5 plus 5. 4 times. That's 10, that's 20. But this is the same 5 plus 5 plus 5 plus 5 is the same as 4 times 5. Or is the same as 5 times 4, which is 20. So m to the power of 5 or to the power of 4 is simply m to the power 4 times 5 or 5 times 4. So m to the power of 5 or to the power of 4 is simply m to the power of 20. M to the power of 20. Let's have a look again at this. Expand and simplify using success criteria 1. 8 squared to the power of 3 means 8 squared times 8 squared times 8 squared, 3 times, because of that 3 here. 8 squared multiply itself 3 times. But 8 squared is 8 times 8, and that 8 squared is 8 times 8, and the other 8 squared is 8 times 8. So that is simply 8 to the power of 6. So when raising a power to a second power, we multiply the indices. We multiply the indices. So 8 to the power of 2 to the power of 3 is simply 8. The base is 8 to the power of 3 times 2, which is equal to 8 to the power of 6. Is equal to 8 to the power of 6. Let's have one more explanation to this. Now, simplify the question here and leave your answer in index form. So let's apply success criteria 2 now, which is applying the index laws 1, 2, 3, or 0 law. We've not done the 0 law yet, so index law 1, 2, or 3. Knowing that index law 3 is power of a power, we multiply the indices. So for 6 to the power of 3 to the power of 4, applying the law is the base 6 raised to the power 3 times 4, which is 6 to the power of 12. Which is 6 to the power of 12. Let's apply index law 3 again. So here we are using the index law 3, which is the power of power. So 2 to the power of 3 to the power of 2 times 2 to the power of 4 times the power of 3. The first one gives you 3 times 2 because you have to multiply those powers, and the second one you have to multiply the powers 4 times 3. 2 times 3 gives you power 6, and 4 times 3 gives you the power of 12. At this point, we now apply index law 1. We're applying index law 3 here, and we apply index law 1 here. Because when you multiply two numbers of the same base 2, we add those indices. So 6 plus 12, that gives you 18. So we used law 3 here in the first step to simplify that part. Up to there, that was law 3 we are applying, and we apply law 1 here to get that. 3r to the power of 3 to the power of 5. That's simply r to the power 3 times 5, which is that. So we are using law 3. Remember, if you're not comfortable with this and you still not master that, you can still use expand and simplify, because r to the power of 3 to the power of 5 is simply r to the power of 3 times r to the power of 3 times r to the power of 3, r to the power of 3 times r to the power of 3. 1, 2, 3, 4, 5, because that power is 5. And once you have that, you can use index law 1, we can use law 1 to help us. If you're using law 1, then it's r to the power 3 plus 3, 3 plus 3 plus 3. 1, 2, 3, 4, 5. And that is equal to r to the power of 15. So we can expand and use law 1, or you can apply law 3 straight away to it. Whichever way you feel comfortable. Whichever way you feel comfortable. So you can expand and use law 1, or you can use law 3 straight away. It's a bit complicated, so take your time to do this. P to the power 3 to the power of 4 multiplying p to the power of 5 to the power of 2. So we're using law 3, power of powers. So you multiply, and power of powers, you multiply. Now that you have used law 3 to simplify to get to this point here, law 3 has helped us to get to that point. At this point, we need to now apply law 1. We need to apply law 1 to add these indices. Our base is P. So we add the powers here to simplify to give us that. So be very careful as you work through this. You will still keep applying all the different laws at different stages as you solve the problem. Right. We have a division, so be very careful. That's a division here. So on this part, you got m to the power of 5 to the power of 3, and we're dividing that by m to the power of 2 to the power of 6. This is just rewriting. As a fraction. The fraction form is easier to look at. Now, let's apply law 3. We apply law 3. So power of power, we multiply the indices and simplify that to get this. Now, at this point, 5 times 3 is 15, 2 times 6 is 12. At this point here, we have to now apply law 2. The base is m. So with law 2, you subtract the indices. And that's what we are doing here. That's law 2. And 15 minus 12 gives us 3. That gives us 3. So we apply law 3 there and law 2 here when we are dividing. When you are multiplying, you apply law 1. When you are dividing, you apply law 2. Now we are changing tack. We want to work on what is the 0 power. So to work on the 0 power, let's complete this table here. Already you would have seen a pattern happening. 3 to the power 5 is 243. 3 to the power 4 is 81. Why is it 81? It's 3 times 3 times 3 times 3. 3 cubed is what? 3 times 3 times 3. And that's 27. This is 3 times 3. And that's 9. That is 3. So that's 3. And that, let's reserve that for a moment. It says, what pattern do you see in the basic numerals? Well, 243 divided by 3 gives me 81. 81 divided by 3 gives me 27. 27 divided by 3 gives me 9. 9 divided by 3 gives me 3. So to find this column here, all that I need to do, because to fill the next column, we are dividing by 3, as you can see. That's the pattern. Do you have any good reason this pattern will not continue? Of course, it will surely continue. So if that pattern will continue, then to find 3 to the power of 0, all that I need to do is I take that 3, preceding 3 here, and divide by 3, and that is equal to 1. So that will be 1. So 3 to the power of 0 is simply 3 divided by 3, which is 1. That's 3 to the power of 0. That's 3 divided by 3. Because you know from law 2, three divided by 3, that's 3 to the power of 1, 3 to the power of 1, is equal to 3 to the power 1 minus 1. And that is equal to 3 to the power of 0 from law 2. So 3 to the power of 0 is 1, which is the same as 3 divided by 3 here. Now, let's digress a little bit before we go and answer that. You see, 2 to the power of 3 is equal to 2 times 2 times 2, which is 8. 2 squared, which is 2 times 2, which is 4. But this 4 is the same as if I took the 8 and divided by 2. 2 to the power of 1 is equal to 2. And why is it 2? Because it is this 4 divided by 2, which is equal to 2. So what is 2 to the power of 0? Again, if you follow the trend that it was 8, 4, 2, from 8 you divided by 2 to get 4, 4 you divided by 2 to get 2. So from this to that, you divide by 2 is simply 2 divided by 2, which is equal to 1. So what is your conclusion? What conclusion do you come to regarding 3 to the power of 0? Well, 3 to the power of 0, we saw that 3 to the power of 0 is simply 3 divided by 3, which is equal to 1. Now we've also seen 2 to the power of 0 is 2 divided by 2, which is equal to 1, because according to law 2. 2 divided by 2 is simply 2 to the power 1 minus 1, which is 2 to the power of 0, which is 1. So you can reach conclusion that any number raised to the power 0 will be equal to 1. And that's what we call the 0 power, but we'll get to that in the next slide. If you have a to the power of m divided by a to the power of m, it means you have all the a's to the power of m all divided by 8, and that gives you 1 over 1 over, which is the same as, for example, if I have 2 squared divided by 2 squared. 2 squared divided by 2 squared is equal to 1. But in terms of logs, in terms of indices, 2 to the power of 2 minus 2, which is equal to 2 to the power of 0. That's the second log, and that's equal to 1. But this can also be written as 2 times 2 divided by 2 times 2. 2 cancel that, 2 cancel that, and left with 1. So whichever way you look at it, you end up with 1. So a to the power of m divided by a to the power of m is simply a to the power m minus m, which is a to the power of 0. And that is always equal to 1. So the 0 power, a to the power 0, is equal to 1 for all non-zero bases. In other words, your base cannot be 0. That's the exception. Any term except 0 raised to the power of 0 is 1. So even if you have 2a in bracket to the power 0, that result will be equal to 1. That result will be equal to 1. And this is what we refer to as the 0 law. The 0 power of indices. Apply the 0 power rule to evaluate. Now, evaluate means we want the final answer. Minus 3 to the power of 0, and you can see the bracket covers all that. So the answer is equal to 1. If the question was minus 3 to the power of 0, this one, the answer is minus 1, because the power 0 is only for the 3. The minus sign is there. So that will be the answer. But minus 3 to the power of 0 is equal to 1. That's why the bracket is there. So note the difference between the two. So for this, you can see that the minus is behind the bracket. So the answer is minus 1. Now, 2y to the power of 0. So the power 0 only affects the y. So that's why you have 2 times 1, because it's 2y to the power 0. So 2 times 1. All this is 1, but there's a negative sign here, so minus 1. 2 times 1 is 2, minus 1 is 1. That's how we apply the 0 law. Some problem solving question here. There are 11 rabbits on Mount Barrow at the start of the year 2000. I'll underline that because it's very key to the question. The rule for the number of rabbits n, after time t years from the start of the year 2000 is given by that. Find the number of rabbits at 1, t equal to 2 years, t equal to 6 years, and t equal to 0, and so on. Right. Let's solve the problems one by one. So let's look at question A. We have that. Again, we will still apply FSSU, which is formula, substitution, simplify, units. Find the number of rabbits at time t equal to 2, where we know the formula is n equals 100 multiplied by 2 to the power of t. That's the formula. We need to do the substitution. So n will be equal to 100 times 2 to the power of t is 2, so to the power of 2. This will be equal to 100 times 2 squared is simply 4. So n will be equal to 400 rabbits. And was 400 rabbits. So that's your simplify and the unit. In this case, rabbits. T equal to 6, that's given to us. So again, we write n was 100 times 2. T, that's the formula, write that first all the time, 100 times 2 to the power of 6. We substitute, and then we simplify. Now, 2 to the power of 6 is 64. So, because 2 to the power of 5 is 32. So, 64. So, n will be equal to 64, 6,400 rabbits. Again, if you look at that, I've done the formula, I've done the substitution, I've simplified, and I've got the unit. Right, t equal to 0. Again, write the formula. Let's do the substitution. Let's simplify. 2 to the power 0 is 1. So our n equals 100, which is the number at the start. Because at the start we had 100. T equal to 0 is at the start. Rabbits. T equal to 0 is at the start. So that is what it means. Right. So all the time, remember, for calculations like this, do your formula, write it down, substitute, simplify. Probably you need a calculator to do that. And always remember your units. Helps you to set out nicely and logically. Question B. Find the number of rabbits at the beginning of 2003. Well, at the beginning of 2003, remember we started at 2000. So 2003 minus 2000, that gives you 3. So your t is equal to 3. And we want to find the number of rabbits. Number of rabbits So n equals 100 times 2 to the power of t. You need to write that. So again, what you have is simply 100 multiplied by 2 to the power of 3, 100 times 8. So n will be equal to 800 rabbits. 800 rabbits. Right. Let's look at the next one. So here we are looking at 2007. Now, at 2007, because we started from 2000, so 2007 minus 2000. That gives us 7. So t is equal to 7. If t is equal to 7, you have n. The number of rabbits is given by 100 times 2 to the power of 7. Right, 2 to the power of 7, we know that 2 to the power of 6 is 64 times 2, that will be 128. So 100 times 128. And 128 times 100, we just simply add the zeros. 12,800 rabbits. That's our n. 12,800 rabbits. Now, for 2010, so 2010 minus 2,000, that gives us 10. So it tells me that my t is equal to 10 years. If t equal to 10 years, then your n, the number, is equal to 100 times 2 to the power of 10. Now, 2 to the power of 10, that is going to be 1024. 2 to the power of 10, you can just grab your calculator and do 2 to the power of 10. And this will be equal to 1024, 0, 0, which is 102,400 rabbits. And that's the number of rabbits. That's the number of rabbits. Always remember formula. Should have written the formula here, n equal to 100 times 2 to the power of t. That's the formula. That's the substitution. That's the simplified. That's the units. We're counting rabbits here, the number of rabbits. Okay. So to summarize, we looked at index law 3 and we looked at the zero power. Our success criteria was to expand and simplify, and also to apply index laws 1, 2, and 3, and the zero power to simplify algebraic expressions. Additional work and extension work. Please complete the companion workbook questions, which is attached. Show all the required working out. Additional work can be found at your online homework, which is Education Perfect, relevant to the lessons that we have done so far. Kindly remember to do the checkout at Google Classroom by selecting yes, I've watched the video, so that I can keep track of students who have participated in today's lesson. Of course, you can keep yourselves updated with new videos I'll upload on YouTube if you subscribe to my channel, Tabi Maths, if you like to. Yes. There are questions that I've also included in this today's lesson. Please go over them again, all those questions which were completed in today's lesson, all the questions in the video. Please go over it one more time. Thank you very much for your participation. See you next time. Bye.